Dear students, this lecture we are going to derive, we are going to discuss radiation pattern of alternating current element as well as radiation pattern of certified vertical dipole and horizontal dipole as well as monopole and others. So let us first discuss regarding. Let us first discuss regarding the radiation pattern of radiation pattern of alternating current. Alternating current element or called as potential dipole, small dipole that is nothing but H. Okay, so radiation pattern alternating current element. So if you want to draw the radiation pattern, you want to draw the radiation pattern. So the radiation pattern I have already studied is classified into two types. One is field pattern and the other one is power pattern. Okay. So coming to the field pattern, I have studied E plane, H plane. So H plane is called as horizontal plane. E plane is vertical. Okay. So how to draw this E plane or in field pattern? How field pattern? So field pattern. Field pattern. How to draw this? Vertical pattern, or it is called as E. So we have discussed in this first unit. It is the graph of it is the graph between it is the graph between normalized field versus theta, keeping pi as constant. Keeping pi as constant. Similarly, how to draw the horizontal pattern? Horizontal pattern or H plane. It is nothing but it is the graph between normalized field pattern versus by keeping theta as constant. Keeping theta as constant. Okay. So let us draw the vertical pattern and let us draw the horizontal. First of all, here we are saying the term normalized field pattern. What is the form of the normalized field pattern? Normalized field pattern means it is E of theta comma phi by E of theta comma phi max. Okay, so this is the normalized field pattern. Okay, so E of theta comma phi is equal to E of theta. This is called the normalized field pattern. This is called a normalized electric field. What is the formula? E of theta comma phi by E of theta comma phi max. Now we are going to derive the radiation pattern for alternating current. Okay, so already we have derived the electrical field E theta. E theta. So for alternating current element, we have derived it as theta is equal to IDL sin theta by 2 lambda. So this is the expression we have derived. Okay. So electrical field strength of alternating current element E theta. Electrical field strength of alternating current element is given as E theta is equal to eta IDL sin theta by 2 lambda. Okay, now let us go for vertical pattern. Vertical pattern means em of theta comma phi versus theta, keeping pi as constant. Keeping pi as constant. So Before that, first of all, calculate the en of theta comma phi. So it is e of theta comma phi. This is the value of e of theta comma phi. What is the value of e theta on this? E theta comma phi max. What is the maximum value for this? So it is the maximum value is eta ideal by 2 lambda r per theta is equal to 90. So the maximum value is in this, the maximum value of sin theta is 1. Okay, so e theta is equal to theta. So this is e of theta comma phi, this value, this is, okay, now calculate the normalized field pattern. So what is the normalized field pattern? M of theta comma phi is equal to e of theta comma phi by e of theta comma phi max. So it is theta into ideal sin theta by 2 lambda by theta into ideal by 2 lambda. So you get sin theta. So the normalized electric field pattern is equal to sin theta. So you simply draw the graph, okay, for theta, and that is en of theta comma phi. It is equal to sin. For theta is equal to 0. What is the value of sin theta? For theta is 30 degrees. What is the value of sin theta? Plus cancel, it is x. Okay. Sin 45. It is by 42. Okay. So similarly sin 90. It is 1. Similarly sin 180. It is 0. Okay. Like that. If you draw the vertical pattern, it will be like this. The vertical pattern will be simply like this. So the vertical pattern is okay. So this is a theta is equal to 0. This is maximum theta is equal to this is equal to 180 degrees. Okay, like this. Okay, so this is vertical pattern. Okay, so this is 90 theta maximum value. Okay, so theta equal to 90 degrees. The maximum value 180 degrees, like this. So similarly, horizontal pattern. So how to draw the horizontal pattern? En of theta comma phi versus phi, keeping theta as constant. Keeping theta. So in this expression, we are not finding any phi comp. Okay. Let us assume theta is equal to 90 degrees. So what is the value of sin 90? 1. So the horizontal pattern. So the horizontal pattern will be this, because there is no phi term. Okay, so here cos theta is equal to 0. So this is the vertical pattern for some alternating current element, and this is the horizontal pattern for alternating current element. Alternating current. Similarly, now let us discuss a very important radiation pattern for radiation pattern of center fat type. Okay. Do you understand this? The same thing you can proceed for horizontal type. Here also same thing. Okay. So we know that, okay, the electrical field strength. Okay. So the electrical field strength of a center fat type center fat type is given as E is equal to 60 into Am by R to cos theta L cos theta by 2 minus cos theta L by 2 by sin theta. So this is the value of E of theta comma. Okay. So E of theta comma. So what is the value of E of theta comma pi max, E of theta comma pi max is equal to this 60 Im by, okay, so 60 Im by R. Okay, so now what is the expression for a vertical pattern? For vertical pattern, what is the formula? Vertical pattern means it is the graph between normalized field strength versus theta keeping phi as constant. In phi as constant. Okay. So Tn of theta comma phi is equal to E of theta comma phi by E of theta comma phi max. Okay. So what is the value of E of theta comma phi? See the value of E of theta comma. What is the value of E of theta comma phi max? See the value. Okay. So simply divide that one with this one. Okay. So it's the ratio of 60 Im by R to cos theta L cos theta by 2 minus cos theta L by 2 by sin theta by, what is the maximum value? Is 60 Im by, so this one and this one get cancelled. So finally, what is the expression? Say n of theta by is equal to cos of theta L cos theta by 2 minus cos theta L by 2 by sin, sin theta. Okay. So this is the expression. This is the expression. Okay. Now see here. Here, for example, n of theta. What is the expression? N of theta comma phi is equal to cos theta L cos theta by 2 minus cos theta L by 2 by sin theta. Okay. So let us assume that for a half wave dipole, let us assume that for half wave dipole, for half wave dipole, what is the value of it? L is equal to lambda. So simply substitute that Tn of theta comma phi is equal to cos of, what is the value of beta? Is 2 pi by lambda by 2. The value of L is lambda by 2. Okay, lambda by 2 cos theta by 2 minus cos of 2 pi by lambda into lambda by 2 by 2 by sin theta. By sin lambda will get cancelled, 2 get cancelled. Lambda will get cancelled, 2 get cancelled. Okay. So what is the final value? Yeah, now this is the final expression. Okay, you can substitute or you can calculate. You can calculate for any length. Okay, so you can calculate for any length simply substituting L depending upon it. For example, you want to calculate if the length is L is equal to lambda or L is equal to 3 lambda by 4, any length. Okay, so this is the procedure you can proceed. So here now theta comma phi. So I am going to calculate for half wave dipole for L is equal to lambda by. So n of theta comma phi is equal to cos of, so here we are getting pi by 2 cos theta, pi by 2 cos theta minus here cos pi by 2. What is the value of cos pi by 2 is? Cos pi by 2 is 0. Okay. Pi sin theta. Okay, so this is the expression for normalized field pattern for half wave dipole, for dipole, for half wave dipole. Okay, so similarly, you can calculate the value of L. Okay, so anything L is equal to lambda or L is equal to 3 lambda. Okay, how to draw the plot for this? Okay, so same. Okay, so this is the expression. So what is the expression for after I put En of theta comma phi is equal to cos of pi by 2 the value cos of pi by 2 cos theta by sin theta. Okay, so let us go for vertical pattern. Vertical pattern, or it is also called as E-plane. Okay, so what is the expression? It is the graph of En of theta gamma phi versus theta. Okay, so simply in the place of theta, okay, keep different values. Okay, let us draw the graph like this: theta value and En of theta gamma phi. For example, theta is equal to 0. What is the value of theta is equal to 0? Sin 0, 0. And cos 0, what is the value of cos 0? Cos 0 is 1, cos by 0 by 0, you get. Okay, so in the form, we will apply the last W. So similarly, 90, what is the value? X, Y, 180 degrees. So based on this, you can draw the plot. Okay, so based on this, you can draw the plot. If you draw the plot, you get, so vertical pattern for F is equal to lambda by 2 to the power, the pattern is this. Okay, so this is what it is 0 degree, this is what it is equal to 90 degrees. Okay, so this is what L is equal to lambda by 2. Similarly, how will you draw the horizontal pattern? Horizontal pattern. Okay, so it is EM of theta gamma phi versus phi. In this expression, there is no phi term. Okay, in this expression, there is no phi term. Let us consider theta is equal to 90 degrees. Okay, so 90 degrees means you get 1. Okay, so the radiation pattern okay, like this. Okay, so this is vertical pattern for theta is equal to 90 degrees. Okay, so this is the radiation pattern for half wave dipole. Okay, now let us draw pattern for various lengths. Okay, so vertical patterns for vertical patterns for various lengths. For various lengths. Let us consider first for n less than lambda. Similarly, n is equal to lambda by 2. Similarly, n is equal to lambda, and L is equal to 3 lambda by 2, and n is equal to 2 lambda. Okay, so the radiation patterns will be like this. Simply here, for example, L is equal to lambda. What will you do? What is the formula? So here in this expression, in the place of L, the place of L, you simply substitute L is equal to 2 lambda. Then you will get the equation, this equation. Okay, from that you can easily draw. You can easily draw. So once of trying this, you get the pattern like this. So this is for L will be plus the lambda. This is for L is equal to this is for L is equal to this for 3 lambda by 2. This is for L is equal to 2. L is equal to 2 lambda. Okay. So this is for vertical pattern for various lengths for half wave dipole. Okay. So similarly, the same thing for vertical pattern for quarter wave monopole. Quarter wave monopole. So what is the monopole? With the difference here? This is nothing but our, this is our half-wave dipole. Quarter-wave monopole, which we have only one leg, and we consider the imaginary part. Okay, so the same thing here. Whatever the patterns we are having, whatever the patterns we are having, only one part will be available, and the remaining part, okay. So that is, for example, here, let us consider for less than lambda, that is equal to lambda by 2, that is equal to lambda, and L is equal to d lambda by 2, L is equal to 2 lambda. So the same patterns. So this is good here. This is what we are equal to this, negative this. Okay. So here my pattern will be like this. This is match people. Okay. This is what I will do. Lambda. So nothing but this. Okay. So these are the quarter wave one. Okay. So after one we get real part and bottom one we get imaginary part. This is for half wave. This is for dipole. Okay. So this is for quarter wave mono. So these are all for vertical effect. These are all means your antenna is kept vertically at point of. Okay. For example, if it is horizontal dipole. Okay, horizontal. Vertical means like this. Horizontal means like this. Okay, so if it is horizontal dipole, so for horizontal dipole, a radiation for center pattern horizontal dipole. So with the radiation pattern for center horizontal dipole. So here for horizontal pattern is same horizontal pattern. So here E theta will becomes H5 and H5 becomes E theta here. Theta is equal to 90 degrees. See the one. This is our vertical pattern. Vertical pattern is like this. Okay. Whatever I have got horizontally, the things will get vertically. Okay. And okay, whatever the things we have got. This is for f less than lambda. This is for L is equal to lambda by 2. This is for L is equal to lambda. This is for L is equal to 3 lambda by 2. This is for L. Same thing. Okay, here whatever the things we have got horizontally. Okay, here we have got horizontally. So it is centrifugal. Okay, so vertically type centrifugal vertically dipole. This radiations are at centrifugal horizontal type. Okay, the same diagrams. Here we have got the radiation pattern like this. Now they have changed like this. Okay, so this is all the brief description of a radiation pattern of small alternating current element as well as centrifugal horizontal dipole or vertical dipole.